Assalamu alaikum wa rahmatullahi wa barakatuhu. This is Dr. Najan, and I hope you all are fine in every respect. So, today is the session of the past paper questions, paper 2 of the topical work energy and power. So, this is session 1, the first session of the topical past papers. So, before starting the session, kindly recall all the topical aspects, and if you don't check the lecture of work, energy, and power. So I will give you a link in the description and an I button. So you can check this lecture before watching this video. Okay. So you will better understand the concept of the work, energy, and power. And before starting the session, please like, share, and comment in the video. And if you don't subscribe the channel till yet, so please subscribe the channel and inform the other students as well. So let's start. So in this question number 1, this is a graph of extension against the load for a spring which obeys Hooke's law. Actually, Hooke's law is the topic related to the deformation, and according to the Hooke's law, load is directly proportional to extension. Once we increase the load, so definitely extension will also be increased. So the graph is actually a straight line is your origin one because this is directly proportional. Okay, according to the Hooke's law. So state the word used to describe the energy stored in a spring that has been stretched or compressed. So remember that if we are using the stretched concept in a spring, that means this is your elastic
Yes.
potential
Right.
energy. Okay, elastic potential energy, or you may write elastic energy as well. Now in this figure, the train has mass of 250 kilogram at the stop by the compressing a spring in the buffer. After the train has stopped, the energy stored in the spring is 0.48 joules. So calculate the initial speed of the train. So we know well about the motion energy, that is 1 upon 2 m v square. And if we have
Please.
the value of energy, that is 0.5 is equals
0.48.
to 1.2 multiply 2.5 into v square. So 0.5 multiplied by 2 over 2.5 is equals to v square.
Yes.
And then on further calculation, that if we take square root on both of the sides,
Yes.
so we will get the value of v, that is 0.62 meter per second. Now, question number two. Figure
Hmm.
2.1 shows a conveyor belt transporting a package to a raised platform, and the belt is driven by motor. The mass of the package is 36 kilogram. Calculate the increase in gravitational potential energy if
Hmm.
the package raised on a vertical height of 2.4 meters.
So
So,
gravitational potential
yes,
formula.
formula is the gravitational potential energy. Just your EP is equals to m g h.
H.
So we know m is 36, h value is 10, and height is 2.4.
Yes.
So the value is
864.
864 joules. Now, in the next part, we have energy.
So what power?
Calculate the power needed to raise the package if the time period taken as 4.4 seconds. So
Hmm.
you know well about the power is equals to energy over time. So
Okay.
power is equals to, we have energy
8 over 4.
864 over 4.4. So this is about
196.36.
196 watts. 0.36 watts.
36. Yes.
So this second part is interconnected with your first part. If you
So,
calculate wrong.
sir, they have tried to trick us by telling us the vertical height of 2.4 meters.
Hmm. So don't need over that because the vertical height is same in the first part. So we have already calculated the amount of energy. So we will just
Yes.
use that energy and
Hmm.
divide it with the time. So we will get the actual
Okay.
power.
Okay.
Now, in the part C, the electrical power supplied to the motor is much greater than the answer to B. Explain how the principle of energy conservation applies to the system. We know well one
Hmm.
thing that we don't receive a particular amount of energy as the output, and most of the energy is actually is wasted in the form of heat,
Hmm.
in the form of
Yeah.
friction, in the form of sound.
Yes.
So
Hmm.
once we know that the electrical power supply to the motor is much more greater, so according to the principle of conservation, that energy
It's lost due to
is
resistance.
transferred from one form to another form and is dissipated
Wasted.
into the surrounding,
So can you just write that energy is
into the surrounding,
lost due to
yeah,
So if you just try that, will you get it correct?
in the form of heat due to
Friction.
friction and sound. Okay. Now Assume that the power available to raise the package is constant and a package of mass greater than 36 kg is raised through the same height. Suggest and explain the effect of this increase in mass on the operation of the belt. So definitely, if the mass is
Sir, more
increased,
power will be required.
more power will be required because of the increase in potential energy. Okay,
Oh.
and definitely one more thing, it will take more time than the
Oh.
usual. So this is for the 3 marks. So how can we write 3 reasons? Number one, there will be increase in there will be increase in potential energy because mass is also increased. The second reason will be more power is required to raise the heavy mass. And the third point you may take, if power is constant as mentioned in the question.
Yeah.
If power is constant, then the speed of belt will be
Sir, I don't
reduced
understand much.
and take more time.
Sir, if it's written here that power is constant, then why are we writing more power is required?
No, actually, the reason is that more power is required to raise the heavy mass. But,
Considering this,
but, if power is constant, then the speed of the belt will be reduced. If we run the motor with the same power, so definitely its efficiency becomes lower, its speed is reduced, and takes more time. For heavy mass, we actually need of more powered motor. But
is it
in this question, the power is constant.
mm,
So it will affect the speed of the belt.
but then there's doesn't count as a reason that more power is required.
No, actually we can write as no, because as per the potential energy content, that the mass is also increased. So definitely if we increase the mass, so we require actually more power. But according to the question is the power availability is constant, so the speed will be reduced
Yes, sir.
and
So that
and it will take more time.
that's only two reasons.
No, this is three reasons. Number one, there will be increase in the potential energy because the mass is also increased, so more power is required. That's the one reason. The second one, if the power is constant, so the speed of the belt will be reduced and takes more time. So we
Yes.
actually use the three terms. Okay. Or if you want to write another point, so you may write like that. Um, More work done is used to uplift the heavy mass. You may add this point as well. Okay.
Yes.
Now, question 3. An athlete of a mass 64 gram is bouncing up and down on a trampoline.
Example.
So this athlete is actually jumping on a stretching object. So again, the state the form of the energy stored due to the
Elastic,
stretching of the surface. Yeah,
elastic.
elastic potential energy. Now, calculate the kinetic energy.
What was the formula?
Yeah, there is a velocity 6 meter per second and we have mass 64. So we can apply
Yes.
1 upon 2 mv square.
So is that the formula for kinetic energy?
Yeah, just you have to write the formula. Formula is your for the 1 mark. So answer will be
1152.
1152.
Hmm.
Now, calculate the maximum possible distance she can travel upwards. And this is your vertical distance. So definitely we will go with the energy formula. Just your mgh. And we will use this energy as per the concept that kinetic energy must be equal to potential energy.
Yes.
So here 1152 is equals to 64 into 10 into h.
Yes.
So 1152 over 640 is equals to h.
Yes. So 1.8, I think.
8 meters, right? So this is 1 mark for the formula, 1 mark for the energy, and 1 mark for your calculation. Okay.
Yes. Hmm.
Now in practice, she travels upward through a slightly smaller distance than the distance calculated. Why? We actually estimate that the person will get maximum height of 1.8 meters, but there is a slightly smaller distance, and this smaller distance is because of,
Principle of conversation. Energy.
yeah, but what is actually the reason? Maybe air resistance, air resistance,
Hmm.
or thermal energy.
Yes.
Okay. So what is the point of x? This is the deformation.
State the name of the point X.
Yeah, this is actually called limit of proportionality.
But I haven't studied this now.
Actually, limit of proportionality is that particular point. After that, you will not get the maximum stretchness. Then
You will
after this particular point, you will observe in the graph that what your graph line is not going to straight. That means your body is may deform or change their shape. Okay. If it is moving, is beside that a very straight line, so that means this is under your actual content. Now, state one of the law. What is the law in between load and extension, as we discussed in the question number one as well? The name of the law
Hooke's
is
law.
Hooke's law.
Hooke's law.
Hooke's law tell us what? Load is directly proportional to
Extension.
extension under elastic limit. Yeah, within elastic
Yes.
limit. So the x is actually the elastic limit.
Oh. So, but
Now in the question number four, an electric train is initially at rest at the railway station. The motor causes a constant force of 360,000 newtons to act on the train, and the train begins to move. State the form of energy gained by the train as it begins to move. So remember one thing,
kinetic energy.
exactly, the motional energy is your kinetic energy. So we have to write the name kinetic energy. The train traveled at a distance of 4 kilometers along a straight horizontal road. Calculate the work done during the journey. Now we have the force here and we have the value is in kilometers. So first of all, you have to convert this kilometer into meters. Okay.
4,000.
So
4,000.
yes, 4 kilometers is equals to 4,000 meters. This is your conversion. And you know, work done is equals to force into displacement. So this is your 360,000 multiplied by 4,000.
So work done is force times.
Yeah.
Force times what?
Mhm. Is this 1.4 exponential 9 joules?
So,
Now in the next part, asking for calculate the maximum possible speed. And so again, we will use the same methodology. We know that work,
elastic limit.
no, no, work is also form of energy. So work is equals to kinetic energy.
Hmm.
So this is your work done is exactly your kinetic energy as well because body is in motion.
Yes.
So we can apply the kinetic energy formula over here, half mv square. Okay. So we have kinetic energy. That's your
Hmm.
1.4 exponential
Yes.
9
Hmm.
is equals to 1
Hmm.
over 2 multiply. You have mass 450,000
Yes.
into v square. So 1.4 exponential 9 multiplied by 2 divided by 450,000 is equals to v square. 78.88 meter per second.
Yes.
Okay. Now, in practice, the speed of the train is much less than the value calculated. It's the same reason that we have done it earlier.
Yes.
What should be the reason?
So the reason
Krish.
should be that some energy is lost in the form of heat due to
Yeah,
friction and
but we can use a single word now because the train is moving on a road, on a track, you can say horizontally.
sound.
Yeah, but there is
Huh.
friction or air resistance. Okay. Now, after traveling 4 kilometers, the train reaches its maximum speed as it continues at this constant speed on the next section of the track, where the track follows a curve, which is a part of a circle. State the direction of the resultant force on the train.
Towards the center.
Good. Whenever we move in a circular way, so the direction of motion is always along with
Towards center.
toward the center. It will be like this. If our object is moving
So,
around
but
the center.
isn't this other topic?
Now in the question number 5, solar energy is renewable or non-renewable?
The solar energy is non-renewable.
Is non-renewable. Really? It is renewable, Abdurrahman.
So how?
Solar energy, sun energy is a renewable energy. Solar
Yes, yes.
panels. And is it polluting or non-polluting?
It is non-polluting.
Yeah. So we may mark arrow over here. And what
The
about
natural gas, it's a
natural
fossil fuel.
gases, fossil fuel,
Non.
non-renewable, and also polluting? Now, coal-fired power stations state one advantage of using coal as a source of energy. Number one, widely available.
Less expensive.
But now we cannot say that coal is less expensive because coal is very expensive nowadays. तो वो रीजन अब चला गया जिसमें हम लिखते थे ना रिलेटिवली
Hmm.
चीप तो इट इज नॉट चीप हम ये लिख सकते हैं वाइडली अवेलेबल
Cheap in the long run.
एंड कैन बी यूज्ड can be used on a large scale, right?
Reliable.
You can say a coal-fired power station generates electricity at night when it is not needed. Some of this energy is stored by pumping water up to the mountain lake. When there is high demand for electricity, the water is allowed to flow back through turbines to generate electricity. On the occasion, 2.05 exponential 8 kilogram of water is pumped through a vertical height of 500 meters. Calculate the weight. Calculate the
Okay.
weight. So what is
Yes.
weight exactly? W is equals
So
to mg.
M.
Simple. So W is equals to 2.05 exponential 8 multiplied by 10. So very simple. That is 2.05 exponential 9
Yes.
newtons.
So 205,000,000,000.
Yeah, exactly. So we can use as exponential term to save our time. Calculate the gravitational potential energy. So we know that about the potential energy is equals to mgh, and we know
GH.
that mg is equals to weight multiplied by height. So we have weight
Hmm.
2.05 exponential 9 multiply height is 500 meters.
Hmm. So 1.025 and 10 exponential 12.
1 point
0.025
exponential
times
12
10. Yes.
joules. Now, this is a part of the efficiency. The electrical energy used to pump the water in a mountain lake is 1.2 exponential 12 joules,
Yes.
but only give us 6.2 exponential 11 joules of energy.
It's one there input over
Calculate
output
the
and one
efficiency.
input
Yes,
over
percentage efficiency is equals to useful energy output over input energy. So, first of all, you will subtract it down that amount of energy. So, answer will be
so I'm getting 193.5.
6.2 exponential 11 divided by 1.2 exponential 12 into 100.
Yes, so it's output over input.
Output over input, na?
I thought input or output. So 51.67%.
51.67%. This is our efficiency. Any confusion? Good. So these are few questions related about the past paper topicals. I hope you clear your concept by solving the further questions of work, energy, and power. So that's enough for today.